So, number one, what is A? Number one.
-1.
Nice. So I tried to leave you guys enough room to show your work like underneath the problems, but I don't want to micromanage where you show it. But we can all agree that A is -1. And what is B?
Negative.
Mm-hmm. And what's our happy little formula that we use to find the vertex? Perfection, -B over 2A. And remember, for some of us, it helps to say the opposite of B over 2A, right? So you want to fill this out. The reason I used up copies on making this is so that we could do these together. So hopefully you're working along with this. In this case, what would the opposite of B be? 4. So we're going to put 4 over, and then what is 2 times A?
-2.
-2. And what is 4 over -2? Yeah, I mean, if I was going to hear 12 voices in unison, I should have heard everyone saying -2. Okay, 4 divided by 2 is, of course, just 2, and a negative divided by a positive, or vice versa, whatever, is a negative. So what we know is that the vertex has an x-coordinate of -2. So it's at this point that you definitely want to be pretty meticulous about the work that you show. And I know you've already been practicing this. The reason I gave you this on paper today, you'll be getting a paper assignment today, is because I want you to practice actually drawing the parabolas now and not having Delta Math just, draw that perfect parabola for you. Today you'll get to experience the joy of trying to make them actually look like parabolas. So anyways, let's keep hammering on the math. So what I'm going to show here, and when you look at my answer key, you'll see I did this meticulously every single time. I'm going to take this thing in the purple box up here, and I'm going to copy it down. And I mean exact. The only thing I'm going to change is where it says X, I'm going to put a blank. So mine's going to say negative blank squared -4 blank -7. I can't stress enough, especially on these harder problems where you have negative values with negatives in the equation, that showing your work meticulously like that is going to go a long ways for you. Now we have to do the math. So I'm going to scroll up a little bit. What's going to go in those blanks? -2. And then the big question, and it's one of those things that just takes time and perseverance. And, you might get 3 kids one day, 12 the next. But the big question is this: what is the answer to the green box? It is -4. And if in your mind you were thinking it's 4, then you kind of missed a really important memo last week. Remember that this negative sign with the arrow pointing at it is kind of a sit aside negative. So when we square the -2, yes, we get 4. And then we put the negative back on and get -4 like that. So great job on the -4. Right? How about this second one? We'll kind of put a little red oval around it. What is the answer to that? I don't know why you whispered that at me. That was really creepy, but it is +8. Thank you for that. +8 is really good. And then I'm going to copy down the -7. Okay. And then what's? Please? Oh, I'm sorry. No, I thought we were doing a thing. We're not doing a thing? Oh, sorry. My bad. What's -4 plus 8? 4. And what's 4 minus 7? -3. So I'm going to put -3 back into my vertex now. And so the instructions say find the vertex and then sketch the graph. So I would say that mission number 1 has been accomplished. Okay. So that means now that I can go to that point. So I'm actually going to go to the point -2, -3. And on my graph, how do I get to -2, -3?
Down 3.
Left 2, down 3. Right. Remember when you graph points that your first number is your X and your second number is your Y. Okay. It's kind of different from slope. So don't get the two confused. We're going to go left 2, and then we're going to go down 3, and we're going to put a big proud point right there. Now, what we're used to is we just click on the screen And delta math makes this perfect, beautiful parabola for us. So, but we do still have to plot some more points. So how will I get to my other points? From that vertex, where will I go? Kind of walk me through it. Out one. Perfect. Out one, down one. And don't fall for the grid lines, okay? The computer program puts the half spots in there. Those are like 2.5, 1.5, stuff like that. So, and then I do have enough room to do one more set of points. So going back to my red dot, the vertex, where else could I go? Out two, down four. So just go back to your vertex and go either left or right. It doesn't matter. One, two, and then down one, two, three, four. Clearly, we're out of room at this point in time. But the computer does a pretty good job. It generates these questions, but it also generates the graph. And so it's going to give you a graph that will fit your parabola. So if you find yourself, like if you had a vertex, I'm going to switch to green, like way up here in this corner, and your graph was supposed to go up like this, that's going to be on you. Okay, that just means you have a mathematical error someplace. The computer is going to give you a good workspace. I do like that. So for the first time ever, you get to try to graph one of these. And the rules with parabolas, there's not a ton of them. And these things do take practice, but you want it to be constantly curving. And there are some rules I'll talk to you about that you cannot break. And so we're going to sketch it down this way, like this, and then like this way. You should practice this at this point in time. So there's a few big rules, depending on how much more time we wind up spending on graphing parabolas. The three no-nos. Eventually, you'll take a quiz over this, and there are three no-nos. Number one, your graph cannot have straightness. Okay, so a lot of times people wuss out and they kind of go connect the dots like this. That'll get you points off. Okay, parabolas are never going straight, they're always curving. Another thing that will get you points off is you might make a really good graph like this. And then at the end, you chicken out and you curve back in. If there's any inward curvature, that's not mathematically okay. These things are functions, okay? And they can't double back on themselves horizontally. And then the third way to get hammered on some points is have it make a really nice graph, and then at the end, chicken out and make it have like a little floppy wing out there on the side. So parabolas do take some practice. If you did not just draw this one, if you're just like sitting here watching me work, you might want to practice because I'm not holding you to account for like perfect artwork. I understand it. There's a little learning curve, but you cannot, non-negotiably, you cannot break any of those rules. No straightness, no horseshoe coming back in, and no little wingy wings going off to the side. And then, of course, like all graphs that go forever, you, of course, have to have the arrowheads on the ends like this to show that it does, in fact, continue on. Okay. So let's do another one together. Number two. So do you have any questions on number one? All right, so number two, kind of the same gist. What's our A value on number two?
1,
I agree. What's our B value?
-8.
-8. Solid. So I would always write those down first. A equals this, B equals that. Now I'm going to start with my happy little formula, which remember is the opposite of B divided by 2 times A. So just fill it in. What's the opposite of B?
8.
So I'm going to go with 8 over, and what's 2 times my A? And what's 8 divided by 2? It is 4. Good. So I'm going to make my vertex up here. I'm going to put 4 blank. So I'm not going to veer off course from what I said before. I'm going to stick to my guns on this one. And you can take the advice or leave it, but I'm going to show my the business end of the function, bless you, over here. And I'm just going to copy it down, replacing the X's with open spaces. So mine's going to say blank squared minus 8 blank plus 12. What's going into those blanks? Positive 4. This one, there shouldn't be any trickeration here. Some problems are created a little bit simpler than others. You don't have any weird stuff with negatives going on here. What's 4 squared? 16 minus what's 8 times 4? 32. And then you do have to, as always, I've been saying this all year, you do have to be able to do like grade school arithmetic. What is 16 minus 32? It's negative 16. And what is negative 16 plus 12? Negative 4. So that's the vertex. We did it. And so we're going to go to that point and we're going to make a dot. So how do I get to the point 4, negative 4?
Right.
Yeah, right 4, down 4. And I will say, if this graph opened downwards, I would be a little bit concerned. I might get a little red flag making me think that I did something wrong. Because you see, I don't have enough room down here to do very many points if it opened this way. So thankfully, though, it does open up. And how do we know it opens up? There's no negative in front of the x squared, right? So we do have an upwards facing parabola. And again, I don't think we're going to have room for any more than the typical 4 points. But if I wanted to, not if, I want to make my first pair, where do I go?
Right one.
Perfect. And then you just mirror that on the other side as well. And then back to the nose of the little almost happy face. Where do I go from there?
Right two.
Right 2 up 4. And then again, mirror that on the other side as well. And then make sure that you're taking the time to practice drawing these in. And if what I do when I graph them is I kind of sketch. It's hard with this board that I'm on, but I try to sketch lightly as I go. And then when I feel like I've made a good parabola, then I kind of go back over it with a little more oomph to kind of lock it in. Okay. Let's do a couple more and then I'll get out of your way here and let you guys practice on your own. Uh, Number 3, what is my A value?
1.
Yes. What's my B value? Nice. So I'm going to plug in my happy little opposite B over to A. And what is that going to look like? What's the opposite of B? Yep, over 2 times A. 2 times 1 is 2. And what's negative 6 over 2? Nice. So that means that the vertex has an x coordinate of negative 3. So I write it like that, just knowing that I've got this space here and that I'm going to fill it in here momentarily after I go do some math. So I'm going to write blank squared plus 6 blank plus 5. And what's going in those blanks? The negative 3 that we worked so hard to find. So now I can scroll up a little bit. I can just focus on this math. What's negative 3 squared?
9.
Positive 9. Yeah, for sure. When you square a negative, it flips up to a positive. And then in the second, kind of the middle portion of this, what is that positive 6 times that negative 3? And then what's 9 minus 18? Negative 9. And what's negative 9 plus 5? Negative 4. So that means now that I can go up to my vertex and I can complete it. And I can say, boom, there it is. What's going to change here in a couple days is that I'm going to start putting a number in front of x squared other than 1 or negative 1. So I'm not going to make that jump here today. I want you to really just to get locked in on the finding the vertex and then just graphing the normal 1, 1, 2, 4, 3, 9 parabolas. So anyways, on this one, it opens upwards. So I'm going to start by going to my vertex, which is at left 3. 1, 2, 3, down 1, 2, 3, 4. And again, this one opens up, which is good. If it opened down, I'd be concerned. So where do I go? Yep, 1, 1. The next one is 2, 4, right? So we go right 2, up 1, 2, 3, 4. That's it. And then again, make sure that you make your graph. So don't think I'm playing around with like, will I take points off? It's not, I don't mean to be this way, but like, again, you can't break non-negotiable rules. So like if I made a pretty good graph like this and I'm coming in solid and I'm like, oh, look at this curve. And then I do this at the end, I'm going to lose a point. Okay. So remember, no horseshoes, no wings, no straightness, all that good stuff. So let's one more and then I'll shut up. Number 4, what's A? Negative 1, what's B? Yep. And then again, the happy little formula is take the opposite of B and divide it by double A. So what is the opposite of B?
2.
Nice. And what is 2 times A? And what's 2 divided by -2? -1. So I can just write -1, comma, space. It's pretty repetitive, right? And so I'm going to take that -1 now and I'm going to put it back into my original problem. And the original problem, be careful, is negative blank squared minus 2 blank plus 2. All right, y'all see what I'm doing, right? I'm just copying the original equation and just changing all the x's into input slots. And then in those input slots, I'm going to put the -1 that we found. -1 goes here, -1 goes here. And then you math. And I only heard a few voices, but as a teacher, we sometimes are like, oh, good, they get it when we hear 3 people say it correctly. I'm not going to ask you all to say it at once because that's like creepy and weird. But what is the answer to the purple box? It is -1. And if you are bashful and don't like to ask questions in front of people and you don't know why that's negative, make sure you find some time to come see me and ask. Try to explain it one more time here. This negative with the green arrow pointing at it, he's a wait his turn negative. He's in kind of a timeout. And then when we square the actual -1, we do get +1. I get that. And then that negative with the green arrow flies in and reattaches. So as we discussed last week, there's no way around the fact that that purple box is going to be a negative. It has to be because of the green arrow guy. Okay. And then what's -2 times -1 in the red oval? +2, so +2. And then I could just copy down the back +2. And again, you can just see how basic math would constantly, you've learned it this year, how if you can't add and subtract correctly, it's been a menace to you all year. What's -1 plus 2? It is 1. And what's 1 plus 2? It is 3. So we now know the vertex is at left 1 up 3. So we're going to head that way, go left 1 up 3. And the placement of that vertex would have you inclined to think that, boy, I sure hope this graph goes down. And it does, because there's a negative right up here. You see him up there? So that's a downward parabola. And again, predictably room for the 4 points that we're used to. So we're going to go out 1, down 1, out 2, down 4. And then you're going to sketch your graph. So, and if your parabolas look astonishingly terrible for like the first 20 minutes, or 2 days. That's totally normal, by the way. Just be persistent and try to hold yourself accountable for saying, am I proud of the way that looks? And if it looks like poo-poo, then do the big kid thing, erase it and do better. It does take some practice, okay? All right, I'm going to hand out your next assignment. It's on paper. That's it. And then I do have a paper answer key up here if you want to look at it. I do have also that paper answer key posted digitally online on Canvas. So whatever I can do for you, let me know. If you need some help, if you can't fit points on the graph again, that's on you. That means you did a boo-boo. Anyone wants to come along to number 3, come along for the ride. Your A value, I assume you know, is 1. Your B value is 4. And then when we plug into opposite B divided by 2A, we should have -4/2. And what does that equal? So we now know this. I'm going to write this in yellow. We now know that the vertex is officially at the point -2 comma something, right? So we're going to head back up to the top. And in this portion, I call it the business end of the function, we're going to copy that down with some blanks. So it's going to say blank squared plus 4 blank plus 2. And into those blanks, we're going to put the x that we found. You found. I just was along for the ride. -2. What's -2 squared? Nice job. Positive 4. And then this second portion right here in the green, you have to just view it as a multiplication. It's like a positive 4 times a negative 2. What's that? Negative 8. Good job. And then the rest from here is just left and right, left to right rule, right? We don't add before we subtract or anything silly like that. We just plus and minus just get steamrolled left to right. What's 4 minus 8? Negative 4, right? And then negative 4 plus 2 is, yeah. So I can now take the negative 2 that is the answer to this problem down here, and I can plug it into my vertex right here. And then that should complete the puzzle of where the vertex is. So my graph's going to look a little bit different from yours because I just kind of I just used a different grid. Same idea though, right? So you and I agree that we're going to go left 2 and down 2, and we're going to make our vertex right there. And then does this one open up or does it open down? It opens up, right? So a normal parabola will do what we call opening up. And so from that vertex, and knowing the worksheet, you probably don't have a ton of space there. Yeah, you're going to have room for the normal, the 4 points that we've been doing. So we're going to go out 1, up 1, and then we're going to go out 2, up 4. And I'm guessing on your paper that you're out of room after that, right? We haven't seen a single one yet. That'll change tomorrow or Wednesday, but we haven't seen a single one yet that lets us go past the 5 points. Does that help? You're welcome. While I'm unpaused, are there any others that you'd like to go over? Huh? The paper one? Sure, no problem. There you go. How you like that? It's colorful. Yeah, I thought so. Pretty nice. All right, I'm repausing. If you guys have more questions, let me know. Be happy to do another. That pen. These ones with the negative in front of the x squared are always going to be the hardest ones. And usually, I'm guessing that you're not getting hung up on the A and the B part. It's usually when we plug it back in. So that's probably where it's, and I'll try to slow down on that. And if I don't do a good job, just let me know and I'll try again. I'm sure you and I agree that A is -1 and that B is 6. And I'm sure we agree on the formula, negative B over 2 times A. So what's our negative or opposite B going to be? -6. And what's our 2 times A? Nice. And -6 divided by -2 is +3. So we can say for sure right now that because we got +3, that the vertex is officially at the point 3 comma something. So usually what happens, and what's nice about these graphs is that if you made the mistake that I think you made, then you can catch it by, a red flag kind of goes up. And so what happens is I'm going to copy this down. And by this, I mean the thing in the red box. And whenever I get to an X, I'm going to put a blank. So I'm going to do Y equals negative blank squared plus 6 blank minus 7. Okay. And notice that the negative is not in parentheses. That's usually where the mistake happens is, anyways, I'll continue on. So we're going to put our 3 into these blanks. So we're going to put it here, and then we're going to put it right here. And then here comes, usually what happens is when we just are talking casually in math, if I said, what's -3 squared, you'd say, well, it's 9, of course. But the thing about this is that only the 3 is getting squared. You see that? The negative isn't part of the x. And so when I say what's -3 squared, maybe a better way for me to phrase that is what's the opposite of, and then pause, like what's the opposite of 3 squared? So when you do 3 squared, yeah, you get 9, but then that negative gets copied, you see? Okay. And that's usually what happens is someone says that that equals positive 9. And then the next part is, of course, 6 times 3 is 18. And then someone goes, holy smokes, 9 plus 18 is 27. And then they go, I can't fit this point on the graph, right? So, and then we'll complete the math. What's negative 9 plus 18? Positive 9 minus 7 is
So in this variant, the negative sign goes with it, only if it's positive.
the negative sign only goes with the x if I'm going to point to something with a very large red arrow. Do you see that red arrow?
Yeah.
If that number's negative, then the negative gets squared. Okay. Do you see my here? I'll make some parentheses. Do you see those parentheses right there? When I put 3 in there, 3 squared is 9, but I only squared the 3 because the negative isn't, it's not, the negative isn't part of the x. It's the negative of x squared, you see. I'm sorry, I'm talking in circles here. Um, Abby, I heard you say something that I didn't like. What's 9 minus 7? Okay, good. I thought I heard you say 3. Thank goodness. So we're gonna 9 minus 7 is 2, and then we're gonna put a 2 there. And so we're gonna go plot the point now. And that's at right 3, 1, 2, 3, up 2. And then where does this graph go? Up or down? For sure. And then how do I get to my next points? Uh-huh. And you do it on both sides. And then your other 2 points? Nice. 1, 2, 3. Good job. And then you'll make the graph. Does that clarify?
Yeah,
Right. And that was all happening because of the conversation that we're all going to have like 19 times. It's in that red oval that almost 100% of the mistakes will happen when there's a negative in front of the x squared. So whenever you see a problem that says y equals negative x squared, in your mind, you should think of it like this. You should think of it as y equals negative and then like move the x squared like an inch over so that you remember to do the x squared first and then assign the negative after you're done. Okay. I hope that makes sense. Good. Any others?